want to find q that satisfies the given conditions. Q has degree 2 and has a root at x equal 1 plus I times the square root of 2. So this is going to have degree 2. Let's see, root, multiplicity, binomial. And this is a lot like our last one in as much as if you have a root at 2i, then you're going to have its complex conjugate, a root at negative 2i. So this one's given, but there's another one that's implied. 1 minus I times the square root of 2. Perfect. Now that has a multiplicity of 1, that has a multiplicity of 1. So altogether I get a multiplicity of 2, or a degree of 2, I should say. Let's move these to the other side. And tell you what, I'm going to move them to the other side this way. I'm going to regard this as one whole term and create a binomial of x minus 1 minus I times the square root of 2 and x minus, that should be a plus here, 1 minus I square root of 2. And, I'm still going to need to play with this a little bit. To get q of x, to get my polynomial here, I'm going to need to multiply these two things together. Before I do that, I want to clean this up a little bit. And I'm kind of regretting that I put these in parentheses the way I did. Let me distribute that negative to both terms here. That's going to be x minus 1 minus I square root of 2. And then x minus 1 plus I square root of 2. So I just distributed that negative to both of those terms. And here's where the trick's going to come in. The trick's going to come in this way. When I multiply a minus b times a plus b, I get a squared plus ab minus ab. Those cancel. I get a squared minus b squared. I'm going to use that trick. If you tried to do kind of the analogous of FOIL, you'd have to multiply the x times all three things here. And then the negative 1 times all three things. Then there's negative I square root of 2 times all three things. That's 9 multiplications. I'm going to reduce your work on this. And let me show you how. Notice that I got x minus 1 in both of these things, right? I'm just going to put that in parentheses. This, now it fits the pattern that I had up above. It's a minus something times a plus something. It's exactly the pattern I have up above. Right? So instead of foiling it out and getting 9 multiplications, I'm just going to say, oh, well, it's a squared minus b squared. What's my a in this one? X minus 1. So I'll get x minus 1 squared minus b, which is I square root of 2 squared. Now we got to be a little bit careful factoring this out. That's x minus 1 times x minus 1 minus, when I square this, I'll get I squared. What's the square root of 2 squared? 2. And now I'm going to FOIL this out. That's x squared minus x again plus 1. What happens to the minus I squared term? What do you think is going to happen there? I squared is negative 1. Yeah, so it becomes positive 1. So it's going to become positive 1 times 2, or basically plus 2. If you collect like terms, x squared minus 2x plus 3. Whew. There it is. That's your polynomial that has a root at 1 plus I times the square root of 2. And then by implication, you're going to have a root as its complex conjugate, 1 minus I squared to 2. Okay. Beautiful. That was a good one to get to. Questions or comments on that one? Let me stop the recording on this.